Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is Furthest building you can reach. So the problem statement goes like this. You are given an integer array heights representing the heights of the buildings, and you are given two things. One is some number of bricks and some number of ladders. Okay, so with bricks you can only bridge a certain amount of gap. Okay, let's say you are standing at this particular building and next building is a taller building. So and let's say the difference is let's say this is 2 and this is 6 and the difference is 4, and you are given bricks equal to 3. Then these are the number of bricks that will be required, so we can assume that one brick can bridge 1 unit of gap. So exactly that number of bricks should be required to bridge the gap. So exactly 4 bricks were required, but we were having 3, so we would not be able to bridge this gap. Okay, it means that let's say if we were standing here, so we would not be able to move to the next building. So let's say if we decide to use a ladder instead of a brick, let's say ladder is also given to you. So for ladder there is no limit how many size ladder can be, so ladder can be extended infinitely. Okay, so it can be used to bridge a gap of 4, or it can be used to bridge a gap of whatever is the maximum height of a building that is possible here. So let's say the maximum height possible is 10 raised to power 6. So then 10 raised to power 6 height gap can also be bridged by a ladder, or it means that we can let's say if this gap have been 10 raised to power 6, then also a ladder could have been used. But for brick the difference should be exactly same as the or lesser than the bricks, equal to or lesser than the bricks, and if it's greater then bricks cannot be used. Okay, so moving back towards the problem statement, you start your journey at the 0th building. So it's if you have a 0 based indexing, okay, it's mentioned here also. Then let's say you were initially positioned here. Okay, so you have to tell uh, you know what is the farthest building where you can reach. Okay, you have to return index of that building, and there are certain rules for moving on the buildings one after another. So, you have to move in this direction. The rules being, if the current height building is greater than or equal to the next height building, then you need not a ladder or a brick. So if you see this particular example, okay, so initially you were positioned here, and you see that this particular building that you are initially on or currently on is larger than or equal to the next building. So you need not to require any brick or ladder to move to the next building, you can just jump off. Okay, so but this is not the case. Let's say if you were standing here and you have to move to the next building, so the next building is taller than the current building on which you are on, so you will be requiring either a brick or a ladder, either bricks or ladder to climb this height gap and move to the next building. So that's what the problem statement is saying here. Now let's move to the second part. If the current building's height is less than the next building height, then you can either use a ladder or these number of bricks. Okay, height of the next building minus height of the current building number of bricks. So this one I have already covered. So let's move further. You have to return the furthest building index. Okay, it's a zero based indexing. You can reach if you use the given ladders and brick optimally. Okay, and before thinking about approach to solve this particular problem, let's see the constraints. So the heights of the buildings will be of order, the heights array length is of order 10 raised to power 5, and the heights of each building will be ranging from 1 to 10 raised to power 6, and the number of bricks that will be initially given to you will be ranging from 0 to 10 raised to power 9. Okay, and the ladders will, the number of ladders that will be given to you will either will be ranging from 0 to the length of the heights array. Okay, denoting the height of each building. So quick observation here is that since we know that ladder can bridge any amount of gap. Okay, ladder can bridge any amount of gap. Height gap, you can say height difference basically, if you want to be more specific. So it is advisable, or you can say it is optimal to use ladder only for larger gaps. So it's optimal to use ladder for larger gaps, larger height differences, or let's say. Okay, this particular observation or idea, you can say, is the crux of the logic to solve this particular problem. Okay, so why so? Because if let's consider a scenario. If initially you are on 2 height building and then there is a 6 height building, okay, and the number of bricks that you were initially having is, let's say, 1, and the 4, and the ladder is also 1. Okay, and then there comes a building which is of height, let's say, 11. Okay, so if you see here, the height difference is 5, here the height difference is 4. Okay, so let's say instead of using 4 bricks here to go from this position to this position, I used a ladder. Okay, so ladder is reduced to 0. Now I have to make a move. I am currently here. Now I have to make a move to this particular building, but for that I will be requiring 5 bricks and I will not be having any ladder since I have already used it. So the number of bricks that I was having is lesser than the number of bricks that will be required, so I will be stuck here only. If let's say we do the other way around, and instead of using ladder in the first go, we used 4 bricks there, then we could have easily moved to the last building. Also, let's say we decide to use the 4 bricks here and we bridge the gap. Okay, now we moved on this particular building, and now we are having a ladder only. So ladder can bridge any amount of gap, as we know. So that's why we will end up on the last building. Okay, so this is a more optimal way. In this way, what we did, we used the ladder to bridge the largest gap that was there. Okay, or let's say more bigger gaps, you can say. So ladder will be used to build bridge larger height differences. Okay, so now what we'll be doing is, we for sure know that we can use, let's say there are n height differences. Okay, so we can only use ladder up to let's say number of ladders are given as L. Okay, so we can only use L ladders, and we should be using them on the largest L height differences. Okay, largest L height differences. And if there is a height difference that is not among current largest L height differences, then we will use bricks to bridge that height difference. Okay, so let me write it clearly. So this largest L height differences will be the running largest L height differences, you can say. What I mean by running is, it will be constantly updated as you move in the heights array. Let's say this is the heights array given to you. As you move in this direction, starting from the very first index, which is a 0th index, so your this largest L height differences or running largest L height differences, to be specific, will be constantly updated. Okay, so whenever there is a height that cannot be included in running largest L height differences, then you will use brick to bridge that height difference. Okay, so let's write it. Whenever there is a height difference, so this height difference should always be positive. It is pretty much well understood. So if there is a height difference which is not among L largest running height differences, then bricks should be used to bridge that gap. To cover that height difference. Okay, and if let's say the number of bricks are not sufficient to cover that height difference, then you will be terminating your search there only. If let's say number of bricks are not sufficient to cover that height difference, and then terminate your search of furthest building. Okay, so this is in a nutshell the whole logic and the approach that we will be using. So now question arises that how we will be maintaining this largest running largest L height differences. L here is nothing but the value of ladders initially that will be given to you. Okay, so let's see how we'll be doing that. For that, what we'll be doing is we will be using a heap data structure. Okay, this particular heap data structure will be a minimum heap, min heap, always be having a height of minimum height on the top, and all the heights will be greater than the top. Okay, so this will be the minimum height. So let's say, or a minimum height difference to be specific. Okay, so let's say there is a height difference which is lesser than the minimum height difference. Okay, so let's say current difference is lesser than minimum height difference in this particular heap that we are using. Okay, so then in that case we'll be using bricks to bridge this height difference. Okay, use bricks here. And if that's not the case, or even if let's say it's equal, then also it's fine, use bricks here. And if that's not the case, let's say current difference, or let's say current height difference is greater than the minimum height difference, minimum height difference where in this particular heap. So in that case you will use these number of bricks and you will push the current height difference into your heap. Okay, that is how you know you will always be having largest L height differences in your running heap. Okay, so this heap will be constantly upgraded as soon as you are moving in left to right direction in the given heights array. Okay, so let's see the implementation, how the implementation goes for this particular approach. So this is the implementation. Instead of this smallest jumps, it should be largest jumps. Okay, so here this particular data structure is the min heap, which will be storing, it will store maximum, or let's say ladders number of largest height differences. Okay, running high differences, you can say. Okay, and this is we just traversing the heights array only once. We will see if what is the value of the jump required. If the jump required is positive, it means that you are on a building that is required to have some bricks or ladder being used to reach to. Then in that case you will see whether the number of jumps, largest jumps that you are having, is lesser than the amount of ladders that are there. If that's the case, you will simply push the values to your heap. Okay, so let's say number of ladders given to you were 4 and you are only having 3 entries in your heap, then you can easily accommodate 1 entry more. Okay, so this is that case. And if that's not the case, let's say you have already reached the limits of ladders being used, so already there are 4 entries, then you have to replace at least one of them, depending upon whether the current difference is greater than the minimum height difference that is there in your heap. So if that's the case, then you will do the replacement. Okay, replacement of what? Replacement of minimum height difference with current height difference, or let's say not with current height difference. You will just remove this minimum height difference and use this number of bricks. Okay, and you will add current height difference to your heap. So if your largest jumps is not empty and the peak is lesser than, or the minimum height difference, you can say here. Okay, minimum height difference in, or let's say minimum jump value in heap. Okay, then you will do the replacement. You will use these number of bricks, which is the minimum height difference. Okay, and you will simply add the current jump required that was there to the heap. And else if that's not the case, you will simply do use these number of bricks to bridge this gap. Okay, and whenever the number of bricks is not sufficient, you will terminate your search and return the index. So whenever the number of bricks is not sufficient, then you will terminate your search. For the furthest building. Okay, and if you were able to reach the very last building, then the very last building will be having an index of size -1. Okay, and you will be returning that in case you are not to terminate your search anywhere in between this loop. So that is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then please ask them in the comment section. Thank you for watching. Have a great day ahead.